Welcome to the DIY Honda Garage channel. The DTC P2183 code indicates a range or performance problem with the Engine Coolant Temperature (ECT) Sensor 2 in Honda Civic models from 2011 to 2015. This diagnostic trouble code can affect the vehicle's engine performance and may lead to overheating or poor fuel economy if not addressed promptly. The ECT sensor plays a crucial role in monitoring the temperature of the engine coolant and relaying this information to the Engine Control Module, ECM. The ECT Sensor 2 is typically located along the coolant passage of the engine, where it effectively measures the coolant temperature for optimal engine operation. Users should record all freeze data and onboard snapshot before starting any troubleshooting steps. It's also essential to check for any additional DTCs, such as P0111, which may need to be addressed first. DTC P2183 relates directly to the performance and range of the ECT Sensor 2. This sensor is essential for monitoring the engine temperature, as a properly functioning ECT sensor informs the Engine Control Module, ECM, about the coolant temperature in real time. Generally, you'll find the ECT Sensor 2 positioned within the engine's coolant passage, making it crucial for the accurate determination of engine temperature. The information relayed by this sensor affects various other functions, including fuel injection timing and duration, along with emission control measures. If this data is inaccurate, the ECM may miscalculate the required parameters, ultimately impacting the engine's performance. A malfunctioning ECT Sensor 2 can lead to various issues, including poor fuel economy and potential overheating, making prompt troubleshooting essential. There are several possible causes for DTC P2183 that technicians should consider during the troubleshooting process. First, poor connections at the ECT sensor terminals may result in insufficient contact, leading to erroneous readings. Next, the ECT Sensor 2 itself could be faulty, failing to provide accurate temperature data to the ECM. Additionally, wiring issues within the harness connecting the ECT sensor to the ECM might disrupt the communication pathway, resulting in the DTC being set. A malfunctioning ECM can also generate DTC P2183 if it incorrectly interprets the signals being received from the ECT sensors. Thorough inspections of these components are essential to determine the root cause of the issue. Always approach the troubleshooting systematically to ensure no potential causes are overlooked. When DTC P2183 is triggered, several symptoms can manifest that may indicate a malfunctioning ECT Sensor 2. One of the first signs of trouble is poor engine performance. If the ECT sensor isn't functioning correctly, it may fail to provide the ECM with accurate temperature readings, causing the engine to run less efficiently. Overheating issues can occur, as an inaccurate ECT reading may mislead the engine into thinking it's operating at a safe temperature when it is not. Additionally, drivers may notice the check engine light illuminating on the dashboard, signaling a need for immediate attention. Furthermore, an improperly functioning ECT could also lead to increased fuel consumption as the engine attempts to compensate for its erroneous readings, affecting fuel injection and air-to-fuel mixture. The first step in troubleshooting DTC P2183 involves conducting a visual inspection of all connectors associated with ECT Sensor 1 and ECT Sensor 2. This step is crucial as it helps identify any poor connections or loose terminals that may be causing the error. When inspecting the sensors, focus on their wiring harnesses and connectors. Any signs of corrosion, wear, or damage should be noted, as these can lead to inaccurate signal readings. If, upon inspection, the connections and terminals appear to be okay, you can proceed to the next step. Conversely, If any issues are detected, these should be repaired, and a repair verification conducted to ensure that the problem has been resolved. This initial inspection can save time and resources by isolating easily fixable issues before further diagnostic steps. The second step requires the use of the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs present in the system. Begin by turning the ignition switch to the on position without starting the engine. This allows the HDS to communicate with the onboard computers and retrieve any error codes stored in the memory. During this process, pay particular attention to any indications of DTC P2183 alongside DTC P2183. If both are present, you will need to address DTC P1116 first, as it takes precedence. If only DTC P2183 is indicated, you can proceed to the next step in the troubleshooting process. Utilizing the HDS effectively here is crucial for identifying additional underlying issues that may not be immediately apparent. In Step 3, you'll need to start the engine and allow it to idle for approximately 10 minutes. This idling duration enables the engine to reach its operating temperature, which is essential for evaluating the ECT Sensor 2's performance. After idling, use the HDS to access the data list, specifically retrieving the reading for ECT Sensor 2. At this point, you're looking for a temperature reading of about 120 degrees Fahrenheit, 49 degrees Celsius, or less. If the reading shows that the ECT Sensor 2 is indicating less than or equal to this temperature, it is advisable to replace the sensor, as it is likely malfunctioning. Completing this step ensures that you're dealing with a faulty ECT sensor if the reading is below expected thresholds, making it necessary to replace the component. Step 4 is crucial for verifying the performance of ECT Sensor 2 under cooler conditions. First, you will turn the ignition switch to the lock position, allowing ECT Sensor 2 to cool down to the ambient temperature. Make sure to note this ambient temperature accurately. Once cooled, switch the ignition back to the on position to prepare for further testing. Quickly check the value of ECT Sensor 2 using the HDS again. The goal here is to compare the recorded value of ECT Sensor 2 with the ambient temperature you've noted earlier. If the value of ECT Sensor 2 differs by 5.4 degrees Fahrenheit or 3 degrees Celsius from the ambient temperature, that indicates a problem, thereby necessitating replacement of ECT Sensor 2. If no significant difference is observed, it may indicate an intermittent failure, allowing further checks on connections and terminals. Moving to Step 5, you will now evaluate the performance of ECT Sensor 1. Similar to the previous steps, start the engine and let it idle for 10 minutes to ensure it reaches operating temperature. Then, check the readings for ECT Sensor 1 using the HDS. Again, you're looking for a temperature reading of approximately 120 degrees Fahrenheit, 49 degrees Celsius or lower. If the sensor indicates this level, it suggests the sensor is faulty, requiring you to replace it and then proceed to a repair verification process. However, if the reading for ECT Sensor 1 indicates a temperature above this threshold, it means that ECT Sensor 1 is functioning correctly, allowing you to move on to Step 6 for further diagnostics. In Step 6, similar to the previous processes, the engine must be allowed to idle for another 10 minutes. This idle time is essential for ECT Sensor 2 to stabilize and provide a reliable reading. Using the HDS, check the data list for ECT Sensor 2's temperature reading once again. You will be looking for an indication of about 120 degrees Fahrenheit, 49 degrees Celsius or less. If the reading meets this criterion, then you should replace ECT Sensor 2, followed by conducting the required repair verification. If the reading is above this threshold, it indicates the sensor is functioning within acceptable limits, allowing you to proceed to the next step for final verification and ensure everything is in good working order. In the final troubleshooting step, you will again turn the ignition to the lock position and let both ECT sensors cool down to the ambient temperature. After noting this ambient temperature, turn the ignition switch back to on and retrieve the values of both ECT sensor 1 and ECT sensor 2 using the HDS. The main goal is to evaluate whether either sensor is differing by more than 5.4 degrees Fahrenheit or 3 degrees Celsius from the ambient temperature noted earlier. If you find a significant difference, the sensor showing that discrepancy needs to be replaced immediately, followed by a repair verification check. If there is no considerable variation in temperature indicated, it suggests that the system may be operating correctly, albeit with an intermittent failure. In such cases, checking for poor connections or loose terminals at both ECT sensors and the ECM is advisable. The repair verification step is critical to ensure that all repairs have resolved the issue effectively. Begin by turning the ignition switch to the on position and using the HDS, reset the Engine Control Module, ECM. This action is essential as it clears any existing DTCs and allows the system to recalibrate itself. Following the reset, perform the ECM idle learn procedure to ensure that the engine management system can adapt to any changes made. After completing these inputs, use the HDS to check once again for any pending or confirmed DTCs. If DTC P2183 is still indicated, it necessitates a review of the wiring and connections at both ECT sensors and the ECM. A complete troubleshooting and verification process is crucial to ensuring that the system is functioning optimally post-repair. Preventive maintenance is vital for the longevity of vehicle components, including the ECT sensors. It's essential to regularly inspect the ECT sensors for any signs of wear, damage, or corrosion, which can lead to malfunctioning readings and trigger DTCs such as P2183. Additionally, checking the wiring harness for signs of fraying or damage should be a routine part of vehicle maintenance. Ensuring connections are tight and free from corrosion is equally important to prevent intermittent issues that could arise from poor contact. This proactive approach can save time and costs associated with unexpected repairs and ensure the vehicle operates efficiently and effectively throughout its lifespan. Practicing regular maintenance can prevent many issues before they escalate. In conclusion, DTC P2183 highlights a performance issue related to ECT Sensor 2, which plays an integral role in optimizing engine performance. Understanding the critical nature of the ECT sensor helps emphasize the importance of systematic troubleshooting to diagnose the problem accurately. Each diagnostic step is crucial, from visual inspections to performance checks, ensuring that less obvious issues are not overlooked. It's also vital to conduct a thorough repair verification process to maintain optimal function post-repair. By adhering to these steps, not only can one resolve DTC P2183, but it also fosters a better understanding of the vehicle's cooling system. Regular preventive maintenance will further ensure reliable engine operation, avoiding issues related to temperature misreadings in the future. Please like and subscribe to the channel. See you next time.